going to determine oxidation numbers. So an oxidation number is the number of charges the atom would have in a molecule, kind of like its charge in a molecule. And it's going to help you identify elements that are oxidized and reduced, meaning transfer of electrons. We're talking about where electrons are going in this reaction. So if you have an element that's oxidation numbers increase, they're oxidized. So if they increase, does that mean it would go from like 3 plus to 4 plus, or it could go from 2 minus to 1 minus? You're still increasing the oxidation number. If you have a decrease in the oxidation number, those are reduced. So if you go from 3 plus to 2 plus, that would be reduced. 1 minus to 2 minus are also reduced. Oh, it might be in a different order. Maybe I switched stuff around so it would flow better. So when we say that something's oxidized or reduced, we're talking about where electrons are going. If it gained an electron, would the oxidation number go up or down, do you think? If it gets one more electron, one more negative, the number would go down because you can add a negative number. If you lose an electron, your oxidation number will go up. So we're going to look at how we assign oxidation numbers. So in free elements, the oxidation number is zero. So if we have just copper reacting with something, copper's oxidation number will be 0. If we have just hydrogen, H2, reacting, it's in its free elemental form because hydrogen isn't always just H, it's always H2. It's still considered the free elemental form, so its oxidation number is 0. So if they're by themselves, they're 0. Ions composed of only one atom, the oxidation numbers are equal to the charge, meaning if it's magnesium ion plus chloride, the chloride ion, each of those ions are going to have an oxidation number equal to their charge. So magnesium would have +2, chlorine would have -1. And the oxidation number of oxygen is always -2, except if we have hydrogen peroxide, which is H2O2, then it would be -4 plus 1, -1. It'd be -1. And the oxidation number of hydrogen is always +1, except when it's bonded with a metal. So if it's bonded with a metal, where are the metals at? Left of the stair-step line. So if hydrogen is bonded to a metal, then it's going to be -1. If it's usually, it will almost always be +1 though.
So if it has a plus charge, is it metal?
Yes. Fluorine is always an oxidation number of -1, and there's no exceptions to fluorine. Fluorine is always -1. All the other halogens, so that group is also -1, except when they're bonded to oxygen, then they're +1. The sum of the oxidation numbers then must be 0 in a neutral molecule, and it will equal the charge of the ion in a polyatomic ion. And oxidation numbers do not need to be integers, so you can have fractions for oxidation numbers. So let's actually go through assigning some oxidation numbers. It'll make a little more sense here. So for HF, how I like to write oxidation numbers, So for a HF, I like to write, let's write this a little bigger. What element do we know its oxidation number? Fluorine is always -1. Now this is going to be a little simple one. So its oxidation numbers go on top of it. This is how I like to write them. And then we're going to multiply down by its subscript, but this case we only have one fluorine, so it's going to be -1 down here. And then to figure out the other one, this bottom needs to equal 0. So hydrogen here must be +1 total, but there's only one hydrogen, so its oxidation number will also be +1. So the oxidation numbers are the numbers on top. And if on a worksheet or something, if you just like put a box around them or somehow label them as oxidation numbers, I'll know that you understand the top numbers are oxidation numbers. Okay. So in H2O, which one do we know? Or oxygen is what? -2, and there's only one oxygen, so the total for all the oxygens are, which means this number here has to be +2, because we want the bottom to equal 0, since it's neutral. But there's 2 hydrogens, so each hydrogen must have an oxidation number of +1.
So your oxidation number would be +1 - 2?
Yep, our oxidation numbers are +1 - 2. Now, the oxidation numbers don't have to add up to equal 0. The sum of all of the oxidation numbers should equal 0.
So when you multiply down, like
if that was O2, you'd multiply down.
Okay.
We could have started with hydrogen, because we know hydrogen is +1 unless it's bonded to a metal, but oxygen is a nonmetal. So +1 times 2 is +2, and then we'd know oxygen had to be -2 and go up. So UF6, fluorine is always what? And how many fluorines are there? So we'd have a -6 down here, a total, a sum of all of the fluorines, oxidation numbers is -6. So uranium must be, there's only one uranium, so each uranium is +6. So there's our oxidation numbers.
What kind of a compound is that?
I'm not for sure what it's used for. ClO3 with a -1. So this one is not neutral. What will we want the bottom to equal? -1. So if you have a polyatomic ion, the sum of all of the oxidation numbers should equal the charge of that polyatomic ion. So which one do we know? Oxygen is -2, so that means the sum of all of the oxygens are, so chlorine must be +5, because we want this to equal -1. So each chlorine is +5 since we only have one chlorine. Nope, that negative just tells us the sum of the oxidation numbers need to equal that. Okay, CF4. Fluorine is always, so the total of all the fluorines, so carbon is, there's one carbon, so we just have +4. Okay, you guys figure out SO2. I'll give you a head start, then I'll work it out. You can help me work it out. Which element do you know for SO2? Is, yep. So we bring that down to be -4. Yep. Positive 4. Now when we look at, we're going to move on to redox reactions here pretty soon. We're going to look at all of the compounds in the reaction and find all their oxidation numbers and then see if sulfur changed from +4 to a different number. If so, then the element was oxidized or reduced, and that's what we're going to use these for. So P4O10.
Yep.
Oxygen's -2. So this has to be +20. So each phosphorus is +5. Yeah. And is that HNO3?
Yeah.
Okay. Now this one has 3 elements. We haven't done one with 3 elements yet. So which one do we know? Oxygen is -2, so that's brought down to -6. What other one do we know? Hydrogen is +1, so we have +1. So now we can find nitrogen is +5. There you go. Another way you could do that one, well, you know hydrogen, but if you didn't want to start with hydrogen, what's NO3's charge as an ion? -1. So if we started with this and this was -6, we'd want just these two to equal -1. So we'd have +5. So that's +5. To make this whole thing equal 0, this would need to be +1. So 2 different ways, get the same answer.